Let's just dive right in. Today, we're not exactly learning to code, we're learning how to think. How to think like a master problem solver. We're going to break down the art of creating a plan, a recipe, really, for tackling any kind of complex challenge. Welcome to the world of algorithm development.
So, picture this. You walk into a gigantic room, and there are literally 1 million books scattered all over the floor. No shelves, no order, just chaos. And it's your job to organize them. The scale of that is just overwhelming, right? That feeling of, oh my gosh, where do I even begin? Well, that is the exact problem algorithms are built to solve.
You see, that library problem, it's really a problem of scale. And it doesn't matter if you're organizing books, or planning a city, or building a brand new app. The fundamental challenge is always the same. How do you bring order to all that chaos? The answer, it turns out, lies in having a structured approach, a kind of universal blueprint for thinking.
And that brings us right to our key term. Now, algorithm development sounds super technical, I know, but just look at this definition. It's simply a step-by-step approach for creating a solution. That's it. It's a recipe. It's a game plan. It is the map that you draw before you ever step foot into that chaotic library.
So what does this master plan, this recipe for order actually look like? Well, it turns out there's a pretty classic 5-step process that works for just about anything, including, you guessed it, our messy library. So let's break it down. Okay, so first, and this is crucial, you have to actually understand the problem. For our library, what does organized even mean? Are we going alphabetical, by author, by genre? That's step one. Then you plan the most efficient way to get it done. After that, you design the specific steps, you implement the plan, actually start moving books, and finally, you test your work to make sure you didn't accidentally stick a cookbook in the sci-fi section. It's just a logical flow from a big idea to a finished job.
Now here's where it gets really interesting. In step 3, that design phase, this is where you have to make a choice, a really big one. Because there are two fundamentally different ways to design a solution, two philosophies that are basically polar opposites, top-down and bottom-up. You can think of it as the architect versus the builder. Let's start with the architect's view. This is the top-down approach. An architect doesn't start by laying a single brick, right? No way. They start with a grand blueprint of the entire building. They see the whole big picture first, and then they work their way down to the details.
This is the core idea right here. It's a concept called Stepwise Refinement. You take that enormous problem, organize 1 million books, and you just start breaking it down. You start with the big categories like fiction and nonfiction. Then you take fiction and break that down into genres, maybe sci-fi, mystery, fantasy. And you just keep breaking things down into smaller and smaller pieces until you're left with a tiny, dead simple task like put this one book on this specific shelf.
So the whole process is incredibly systematic. You identify the main goal, you divide it up, and you just keep refining and refining until every single little step is totally obvious. The whole point is to create that perfect, detailed hierarchy before you take any real action. It's all about having that master plan locked in.
And the upside to this is pretty clear. It's incredibly organized. It makes it way easier to spot mistakes, and it encourages a really clean, reusable structure. But the downside is how rigid it is. You have to do a ton of planning up front. And what happens if you're halfway through and you realize your main blueprint is flawed? Yeah, you might have to tear the whole thing down and start all over again.
Okay, so now let's flip that whole idea completely on its head and look at the builder's approach. This is bottom-up design. So for a minute, forget the grand blueprint. Instead, think like a Lego builder. Someone who starts by building these cool little individual pieces, totally confident they'll be able to connect them into something amazing later on. The core idea here is the exact opposite of what we just saw. You start by solving the smallest, most basic parts of the problem first. In our library, that might mean finding all the books by just one author and alphabetizing that one small stack. You create these perfect little modules first, and then you start combining them to build the bigger system.
The process here feels a lot more, organic. You identify the basic building blocks, you get them working perfectly, and then you start snapping them together. You build a perfectly sorted pile of one author's books, then you combine those piles to create a perfectly sorted genre section, and you just keep integrating upwards until, boom, the whole library is organized.
This approach is fantastic for flexibility. You can start making real progress right away, and it's great for those problems where you don't really know what the final structure is going to look like. But the risk is pretty significant.
You could spend a week building a beautiful, perfect little component, only to realize it doesn't really fit with anything else. It's really easy to lose sight of the big picture. So, there we have it. The architect, with their grand master plan, and the builder, with their collection of perfect individual components. Two totally valid, but totally opposite strategies. Let's put them head-to-head and see how they really stack up.
This table really nails the trade-offs. Top-down starts big, bottom-up starts small. Top-down is all about breaking down, bottom-up is all about building up. In the end, it really comes down to choosing the right tool for the job. If you're building a skyscraper where that blueprint is everything, you're going to go top-down. But if you're creating a set of versatile tools that can be used in lots of different ways, well, that's a job for bottom-up.
Okay, now, it doesn't matter if you're an architect or a builder, you need a way to sketch out your ideas. You don't just jump straight to building the skyscraper or writing the final code. You have to write it down in a simple, understandable way first. And that, my friends, is where pseudocode comes in. It's like the bridge between a human idea and a computer language.
And please, don't let the name intimidate you. Look at this example. It just reads like structured English, right? If a number divided by 2 has a remainder of 0, then print the number is even. Else, print the number is odd. See? It's just a clear, logical set of instructions. It's the plan, written down so that anyone can understand it.
So here's a final thought for you. Every single app on your phone, every piece of software you use every day was designed using one of these two philosophies. So, was your favorite app meticulously planned from the top down like a grand cathedral? Or was it built up from small, perfect, reusable components, like a box of Legos? Next time you open an app, just take a second and see if you can spot the philosophy behind its design.